Let's get started on the last video of section 0.6. This one's going to be about inverse trigonometric functions, and that is the only vocabulary term that we're going to look at this section. So to begin with inverse trigonometric functions, we want to start by saying that none of the 6 basic trigonometric functions are one-to-one. None of them. We can even imagine the graphs of them or check back on slide 8. All of them fail the horizontal line test. So you might remember that the cosine function looks like this. And it's pretty clear to see that that would obviously fail the vertical line test or horizontal line test. And because it fails the horizontal line test, it does not have a natural inverse. But in each of these cases, the domain can be restricted to produce a new function that does not have an inverse. So we could say restrict the cosine function to where we're only looking at it between, say, 0 and pi, and then we could take a look at maybe a function, and actually that's not enough. We would look at it from here to here. And so that function, if we only looked at it in those cases, horizontal lines would only pass through one time, and then we would have a function that did have an inverse. And that's kind of how we produce the inverse trigonometric functions. We start by restricting the domain. So let's begin there with an example. We want to show graphically that the function y equals sine of x from negative pi over 2 to pi over 2 is 1-to-1, and sketch a graph of its inverse. Okay, so I want to do this by hand a little bit, but maybe mostly in Desmos. So here's going to be where we'll start the graph. And we can go with a high of 1, a low of -1. That's the range of the sine function. And let's go pi over 2, pi, 3 pi over 2, and 2 pi. This is generally where we begin with the sine function. And we know that the sine function behaves something. Actually, that's the cosine function. Let's do sine here, here, here. And then if we're going to go backwards a little bit, we would go here, here, there. And this would be what? Negative pi over 2. And this would be back at -2 pi, -3 pi over 2. So if we restrict the domain from negative pi over 2 to pi over 2, we would only be looking at this function here. And I'm pretty sure we could say with confidence that this is 1-to-1. Imagine the horizontal lines passing through. None of those horizontal lines are going to hit this function more than once. And that means it's going to have an inverse. And now we want to sketch a graph of its inverse. But first, let's go over to Desmos and see how we would do this here. So I want to graph y equals sine of x. There it is. In fact, let's change it to blue so it matches with what we're used to. Done. But if we want to restrict the domain, here's how that works. You want to type a brace, and then we're going to say from negative, you can just type the letter pi, pi, and it becomes a pi /2, and then less than x is less than pi over 2. And that's basically what we got, except ours was stretched out a little bit more because I'm bad at drawing coordinate grids, but we're going to have to live with that. So here it is. The inverse of this function, we remember, is symmetric about the line y equals x. So I'm going to change the colors of this one more time too. Let's change that to red. Let's make it dashed. And then let's zoom in a little bit. So if this is going to be symmetric about this line, I can imagine that there are going to be pieces here and then maybe here. And that way, if we folded the graph along that line, we would have symmetry. So back over to our sketch. And what I'm going to do is come in black with y equals x. And then we imagine then this might be something like this. Okay, so now here they are, the inverse inverse functions. So we notate the inverse functions with a little -1 in the exponent place of the 3-letter abbreviation of the functions. But there's another way as well that's not given in your book here in this section, but it's good to be aware of. If you prefix cosine, sine, or tangent with 3 letters arc, so like arc sine, that means the same thing as inverse. So that's just another notational format. And this is an important slide if you ever need to go through the domains and ranges of each of these inverse functions. And keep in mind that inverse trigonometric functions flip-flop or reverse the domain and ranges. So with trig functions, the input is an angle and the output is a ratio. Well, with inverse trig functions, the input then would be a ratio and the output would, of course, be an angle. So when we're asked a question like the inverse cosine of 1/2, we're looking for what angle has a cosine of 1/2. So here they are in graphical form. We tried a while ago to graph the inverse sine, and I think we did an okay job, actually. Here it is. Here is inverse cosine. Those are going to be the two we probably deal with the most. Here is the inverse tangent function. Inverse cotangent is below. And then we have the inverse cosecant and inverse secant and the inverse cosine there. So here are the graphs. Here are the domains and ranges. So there's all the information about the 6 inverse trigonometric functions. And that brings us to an example. Finding angles in degrees and radians, we want to find the measure of inverse cosine of -0.5 or -1/2 in degrees and in radians. So I think that we should practice doing this in our graphing calculator. So I'm going to pull up my graphing calculator here and turn it on. And first, let's do this in degrees. So we got to make sure our calculator's in the right mode. If you look at the top, it says radians there. So we are not in the right mode. We hit the mode button. It's to the right of second. We're going to scroll down to the option where we have radian or degree. Let's arrow right to degree, hit enter, and then we can second quit and go back to the home screen. So then cosine inverse, you might see it above the cosine button. So we have to hit the second button and then cosine to get cosine inverse. And we're going to type in -0.5 in that parenthesis, hit enter, and we get 120. 120. Okay, so then in radians, let's go back to mode and down to radian, hit enter, second quit there. And let's go second cosine of -0.5 this time. And we're going to get something like 2.094395102. So back to my paper here, or my white space. So the inverse cosine of -0.5 is 120 degrees. Now I'm going to recall from my unit circle that 120 degrees is 2 pi over 3 radians. So keep that in mind. And then in our radian mode of the calculator, -0.5 was equal to something like 2.094395102. That's in radians. And I wonder if we could show that 2 pi over 3 and this giant number 2.09 whatever afterwards are actually the same thing. So I'm going to go to the calculator again, and let's just type in 2 pi over 3. And hey, how about that? It actually is exactly the same number. So there's our proof that we're answering the same question. It's just we're giving our answer in 2 separate forms. So that's how you use inverse trig functions on your graphing calculator. And here's example 8, and this will end things for us. We want to solve for x. Sine of x is 0.7, but we want to solve it for all solutions between 0 and 2 pi. All solutions between 0 and 2 pi. So How do you undo a sign? Well, you do its inverse function. So you want the inverse sign of what's on the right. So we have x is equal to the inverse sign of 0.7. And we are looking for answers between 0 and 2 pi. So this implies that I want to be in radians. So let's check out our calculator and let's type in second sine of 0.7. And let's see, we've got 0.7753. So let's say that x is about 0.775. So that is an answer. Does it live between 0 and 2 pi, or does it live between 0 and about 2 or 6.28? Yes, it does. But I wonder if there are any other solutions there. So think back to the unit circle. If you have some angle here, theta, and we know that he has x comma y point here, and the y is the sine, isn't there going to be another angle over here that is pi minus theta? That would be this angle here, be pi minus theta. That would have, this would be negative xy, the same sine value. So there's another angle that could possibly be the same sine. Let's see. So that would be at pi minus x. So let's go to our calculator. And what do we get if we go pi minus this value? And does that live between 0 and 2 pi? Yes, it does. 2.366. 2.366. So there were actually two answers there that we wanted to give. Next up here, we have tangent x is equal to negative 2. So that means that x is equal to the inverse tangent of negative 2. And so we can go back to the calculator and we can go second tangent, negative 2. And we're going to get an answer of negative 1.107. Negative 1.107. And let's see. So that's that value. What do we know about the tangent? Well, we know that tangent is periodic every pi, periodic every pi. And we want to give our answer in the domain between negative infinity and infinity. So basically, this is all real numbers. Okay, well, if tangent values repeat themselves every pi on the x-axis, then this is one of our answers, negative 1.107, plus multiples of pi, where, let's say plus k pi, where k is an integer. So there's actually an infinite number of answers to that one, but we got the first with the graphing calculator. And that ends our videos on trigonometry.